Now that I've given you a fairly simple introduction to the titration curve and how you model it, we're going to do a few things as we develop this lecture a bit more. First of all, we need to appreciate that there are a variety of different ways that I can imagine mixing acids and bases together. So I've got here for you 4 examples of acid-base titration curves. Now what they share in common is that they always involve an acid and a base. There's a strong acid and a strong base and a strong acid, a weak acid and a strong base, a weak base and a strong acid. There's always acid and base, acid and base, acid and base, acid and base. The other thing to appreciate is that they always involve at least one of the acids or bases being strong. Strong, 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 strong. Sometimes there are 2 things that are strong, but there's always at least one that's strong. So that's a nice general rule of thumb. Titrations always involve with an acid with a base, and they always have at least one of them be strong. Oh, you know what? That's what a neutralization is. When we talked about neutralization in the last lecture, we talked about the idea that for a neutralization to occur, I had to have an acid and a base and at least one of them strong. And if that was the case, then I would be able to do a neutralization and look at the products on the other side. Titrations are nothing special. Titrations are just neutralization reactions. So if you don't neutralize, you aren't titrating. You'll notice I never have a weak titrated with a weak, because if I did that, I would just be making a buffer system, and I wouldn't be able to actually have an indication of substantial changes in pH, because I need that big change in pH to indicate that something had gone on, and buffers don't change much. So instead, titrations are always viewed as occurring with something strong that prompts a big change in pH through a neutralization reaction. And here are the 4 examples.